I'm going to go through the 3 mixed review questions that are on the end of the dilating functions worksheets. So problem number 7, we have a bulletin board problem. It has a width of 8x, and actually I'm going to mark that as W for width, and a height, so I'm going to mark this as H for height, of 2x. Each piece has a width, each white piece has a width of 1 foot as shown. So 1 foot, 1 foot, 1 foot. Write a function to represent the area of the shaded region. All right, so the shaded region for area, remember area is equal to height times width. All right, so in this case, area is A of x. Our height, well, all of the regions here have the same height of 2x. And the width is what we want to be careful about because we're just talking about the shaded region. The whole thing is 8x, but we need to subtract out these little 1 foot borders. So there's 1, 2, 3, 4 of them to subtract out. So it would be 8x minus 4. And so this again, the 2x is your height. All right, and this 8x minus 4 is our width. Okay, so part B here, what is the maximum area of the shaded region if the maximum width of the shaded region is 20 feet? So maximum width. Well, let's talk about the width here. That's 8x minus 4, and we're going to make that equal to 20. So I'm going to go ahead and solve here for x. So, add 4 to both sides. 8x equals 24, divide by 8, x is equal to 3. So now I want to use this x value in the rest of this function. So a of 3 is equal to 2 times 3, times 8 times 3 minus 4. All right, so let's see what we got here. This will be 2 times 3 is 6, 8 times 3 is 24, 24 minus 4 is 20. And so the real question is, what's 6 times 20? And I'm pretty sure that's 120, but I'm going to double check. It is 120. And what we want to do here is make sure we attach our units. So area is going to be height times width. Height is in feet. Width is in feet. So feet times feet is feet squared. Clearly I did not give myself enough room to actually do part C. I will just put the work for part C right here. I'm sorry about that. I'll try and make sure that you guys have space in your worksheet. So for part C, we are asked to find the maximum area of the shaded region if the maximum height is 12 feet. So height here is 2x, so I'm going to set 2x equal to 12. Divide both sides by 2, and x is equal to 6. So I'm going to redo this part of the problem, but instead of a of 3, I'm going to have a of 6, because that's what we think the x value is going to be. So let's go. A of 6 is equal to 2 times 6 times 8 times 6 minus 4. All right, so 2 times 6 is 12. And then 8 times 6 is 48. 48 minus 4 is going to be 44. I would highly recommend taking a calculator and doing 44 times 12. So let's see here. 528. The units have not changed, so feet squared. And this a of 6 keeps dropping down each time. Now, there's nothing, a is not a variable on its own. It's a function name, so please don't think you need to do anything to get the a by itself. You don't, okay? So those are the problems that were kind of new this unit. Question number 8 and question number 9, you're asked to solve. These are both quadratics, and so I'm going to solve the first one here. I'm going to put it in standard form. So minus 2x on both sides. So x squared, and I'm going to put this in descending order. We've talked about that now with the quadratics and also with higher degree functions. So x squared, then the x, then the constant, make it equal to 0. I'm going to factor this. So what multiplies to negative 24 and adds up to -2. How about a -6 and a +4? -6 times 4 is -24. -6 plus 4 is -2. So now, just like we did those zeros in the last video, I'm going to take each one of these factors, set it equal to 0, and I'm going to solve it. So x minus 6, let's go ahead and add 6 to both sides. That gives me x is equal to 6. So there's one of my solutions. I'm going to subtract 4 from both sides. X is equal to -4. There is my other solution. All right, so that's problem number 8. You could have taken it to standard form here and then use the quadratic formula with a is equal to 1, b is equal to -2, and c is equal to -24. Totally up to you. I find the factoring in that one to be pretty quick. All right, so let's move on to problem number 9 here. I am absolutely not going to convert this to standard form. I am going to solve this as it is. So what I want to do is start peeling away these extra pieces of information attached to this parentheses set. So I'm going to add 4 to both sides. So -2x plus 3 squared is equal to 14. I'm going to divide both sides by -2. So x plus 3 squared is equal to -7. I'm going to take the square root of both sides. So square and square root cancel. X plus 3 is equal to, now if you try and put the square root of -7 in your calculator is most likely going to give you an error message because it's the square root has a negative underneath it. It's okay. So no big deal there. What I'm going to do though is just leave it as plus or minus, because we put the square root in, -7. That is a horrible 7. Hold on. Much better. Last thing I'm going to do here is subtract 3 from both sides. All right, so x is equal to -3 plus or minus the square root of -7. You do not need to do anything with this answer. I am not wanting any form of decimal, so just leave it as is. Okay? All right, if you have any questions or concerns on any of those 3 kind of review problems, drop me a message or send me an email directly. All right. See you in the next